All right, let's get started. So happy to bring Dan Garisto here to discuss for what is, I guess, 2 talks in a row on non-physics specialist things, but more important stuff.
Well, communication is very important.
Communication, yes. So just to give you a brief introduction, Dan has a physics degree from Columbia, which everybody knows about these days. Columbia. So he has a degree in physics, and then he basically decided to go into journalism. And he spent some internships and other appointments at several places, including Prairie Lab, Nautilus, it's called Science News, which I think is in DC, or I guess going freelance. And he's since been writing for numerous outlets, including Nature, Science, Scientific American, Physics Today, IEEE, you name it, all kinds of different things. And he's touched on a variety of different topics in the publications he's put out, including a lot of stuff on particle physics, the muon, G-2, for instance, Nobel Prizes he reports on numerous times. He's reported on superconductivity, more recently science policy, which apparently is some big thing now. You know, where I know him from is he's reporting on scientific misconduct, which has found its place in several different areas of science, particularly in superconductivity. In the last couple of years, there was some fraud that came out from the Rochester group reporting on high temperature superconductivity. But also, there's been some news on Majorana physics, qubit stuff. Coming out of Microsoft that he's reported on. He's talked about Russian paper mills. Well, I guess there's paper mills everywhere. And other things. So today he's talking about going from arXiv to the stories live. And I'm very interested to know how you get from A to B.
It's non-trivial.
So please welcome Dan Garisto.
Thanks for the very warm welcome, and thanks to JP for hosting me. This will be your second sort of non-research talk in a row, so I apologize for that. But I hope to touch on some sort of differences between journalism and communication. And I hope that there will be some interesting things to take away from this. So just here's a brief outline of what I'm going to go through. I'm just going to give a brief introduction to science journalism, how it works, what some of the principles are. Then I want to talk about science journalism in practice. I have 2 stories about the discovery of the fractional quantum anomalous Hall effect in 2023. Well, the stories are from last year, but the discovery was in 2023. And one of them is a news story in Nature, and the other one is a feature-length story in Quanta. And I'll discuss a couple of differences between those 2 formats. I'll also have a very brief intermezzo to talk about some of the scientific background behind the Hall effect. And I know that there are people in the audience who are more than able to correct me if I get any details wrong. And then I'll go back to the sort of some conclusions and how both of those stories ended up wrapping up. And my hope is that it provides a sort of window into what may sometimes seem like a frustrating black box. You talk to a journalist, something happens, the story gets published, and you're quoted in it. And maybe you're happy, maybe you're not. So hopefully this will provide some insight into the editorial choices that science journalists make with respect to physics. Okay. Just a very brief sort of housekeeping thing. What do we mean by science journalism? I mean 3 things interchangeably, and that is the product. An article could be a news story about the Higgs boson. the set of institutions and actors which sort of create the science journalism, and also the methods that are used in creating the science journalism. So just something to think about when I use the word interchangeably and don't clarify. Okay, what does that look like? Here are 4 recent examples of stories I've written for Nature. 2 of them are about Majoranas, 2 of them are about science policy. You could just see, in general, story has a headline, story has a sort of a subtitle, subheadline, different places call it different things. In general, you know, this is how a story appears. It's got a nice picture on it, it's got a date, it's got a headline. All right. What is the goal of science journalism? Very reductively, I'm going to say that it is to inform the public about science news. Unpacking that a little bit, informing is a little different than what you might have with communication, which is sort of more about education or entertainment. Informing is more, you know, me delivering you the news. It is going to rain tomorrow. That is informing you. I'm not telling you, I'm not educating you about the water cycle. I'm not making a fun graphic about, you know, raindrops coming down. It's just telling you the news. The second thing here that I want to point out is the public. This is, I think, the key difference between journalism and other forms of communication, is that journalists, their first responsibility is not to the newspaper, it is not to their editors, it is not to their sources, it is to the public. And this can have a significant impact. You know, if, for example, I was a press officer at UMD, my first responsibility would be to the university. It would be to you, the scientists, to any of the students here. And what that means is if I was writing about your research, I'm probably not going to include maybe some critiques or criticisms or flaws with your experiment. I'm not going to bug you about, you know, has this been replicated? Those are the kinds of things which matter to the public, but maybe are not kinds of things that would come up in an institution-oriented piece. And the third thing is news. What is news? You know, what is newsworthy? Why do we care about something? Why do you open a newspaper or click on a link? It's because there is something new and interesting and relevant. It could be exciting, it could be just plain necessary. Deciding what is or isn't news is a very large portion of a journalist's job. And it's the kind of thing that really shapes the rest of the coverage. So if you decide something isn't news, you're not going to cover it. If you decide something is news, well, then you have the responsibility to cover it. And we'll get to that in a second. Okay, so what are some of the principles that sort of underlie this? These are taken from a talk that Tom Siegfried, a former managing editor at Science News, gave at KITP many years ago. And the first is this sort of zeroth order principle, which is that the public has a right to know. The public has a right to know maybe because they are taxpayers. The public has a right to know because we all deserve to know about science. The public has a right to know. This is sort of a priori. And it lays the groundwork for a lot of the other principles that we're going to talk about. The first principle, tell the truth. I say tell the truth rather than be correct or, you know, don't get anything wrong, because there are sort of 2 aspects of telling the truth. The first is, yes, placing importance on factual accuracy. You want to make sure you're not wrong. You want to make sure that when you say aluminum, it has 13 protons and not 14 or 15. And yes, I had to check that this morning. It's important to get that right. But there's a second aspect of telling the truth, which is a sort of more amorphous interest in being honest. If, for example, I was writing an article about quantum computers and I said everything, correct. None of the details were wrong. I listed the exactly right coherence times. I still wouldn't be telling the truth if I didn't inform my audience that a quantum computer is not going to replace their classical computer tomorrow. There is an aspect of telling the truth which is about avoiding BS. Okay, second principle, be clear. This is fairly straightforward, I think, but it's difficult to do in practice, and it conflicts with some of the other principles, as we'll see. Being clear is essential to telling the truth. If you are not clear, you are going to obscure the truth. Your reader is not going to understand what it is that you're saying, and they're going to come away with a wrong impression. Be fair. I say be fair here because I think this captures sort of the closest spirit of what I think, and again, I'm being very clear that this is my view of a science journalist should sort of aspire to. And that doesn't mean be neutral or be completely objective. I don't know that either of those things are possible or even wanted. But you want to be fair. You want to hear everybody out. You want to be reasonable. At the same time, if scientist A says climate change is real and scientist B says climate change is not real, I am not going to print both of those things. I'm going to print that climate change is real because that is the spirit of fairness. It also respects reality. Be rigorous. This is a kind of, this factors into every part of the process of science journalism. If you're not rigorous, you can't be sure that you'll be fair, clear, or telling the truth. And finally, be humane. There are a lot of sensitive and controversial aspects of science, and people's careers, their lives are put into this work. And as a journalist, I think it's very important to remember that there is a person on the other end of that email, and it's incumbent on us to remember that as we publish things that can really affect people. So this is my sort of fifth and closing principle, and it's something that I think everyone needs to work on, especially in tough and trying times. Okay, any questions before I move on about the principles? Yes?
What's the relationship, or what's the difference between tell the truth and be rigorous?
Right, good. So being rigorous, I think, is about I would say it's really about the process, So for example, I go through a fact-checking process for every story that I do. I go through claims, I double check things, I will go back and I will, check with a source. Did you mean to say this? Is this, really technically correct? You'll see, I have an example later on where I catch myself in a mistake and let my editor know, hey, we need to change this before publication. Yeah. Hopefully, did that answer your question?
So, about this list, is this your personal sort of, you aspire to this, or is some sort of, it's in your contract, or what is this?
This is a list I'm showing you on a PowerPoint. I do not have it tattooed on my body.
Great, you just come up with this, or it's in your...
I tell you, it's adapted from Tom Siegfried's list. I think that, okay, it's this, I think if you showed this to most science journalists, they would nod and they would say, yeah, this is roughly what I would come up with. That said, there's not that many science journalists, so I mean, it's a small sample size. But I think these are principles that even if you're not actively thinking about them, these are things that journalists have been told at one time or another to do.
Because the reason I'm asking is also, for instance, in your thing, item number 1, tell the truth, no BS, etc. So when I read about quantum computing, there's nothing but BS.
Not in my articles.
Well, maybe not yours, but it never comes up in my use.
Yes, it is aspirational.
Okay, so but is there anything which actually, where science journalists actually, they're required to do something? There's some
No.
consequences?
Just like there's no Hippocratic oath for scientists.
Okay.
I mean, okay, so here's something. If I ever, for example, if I burn a source, if somebody says, I will talk to you and you have to keep it, off the record, and then I go and I spill and I put their name in print, People are going to know that. Nobody's going to hire me. I mean, nobody's going to trust talking to me. There are ethical obligations that I have, and I take them seriously. So, even if it's not enforceable or tattooed on my body, these are things I take very seriously. So, I would like to think other people do as well. That doesn't mean we always live up to them. Okay. All right. So, how does science journalism work? I've got a list of 5 things here. I start off with conceptualization. You think about the idea for the story. You have commissioning. This is when you're talking back and forth with an editor. You say, okay, here's what I think the story should be. Here's how we should frame it. Here's how many words it's going to be. You report the story. You go out and you talk to people. You read lots of documents. You may go back and you talk to the same person again because you talked to somebody else and they said something different. Finally, you sit down and you begin to write the story, and after some long period of time of banging your head against the wall, you finish a draft and you can send it to your editor, and then your editor says, this is all wrong, and they send it back to you, and you send it back to them, and you go back and forth. Anyways, that's what I would like to tell you that science journalism is. This is a very simplified model. I'm going to show you another model in a bit, but for now, let's break this down. So where does a story idea come from? This is probably the most common question that I get asked, and I think the question that journalists get asked most often. People just wonder, where do you get your ideas for stories? I would say that there are basically 2 primary ways that a story idea comes into being. The first is via a press release. This is a press release from a university or a journal, or even a funding agency, and it says, hey, we've got this new result, or hey, the Large Hadron Collider is ramping up for its 3rd run, or hey, there's an asteroid, that has a 98% chance of missing Earth. These are things which get sent out by institutions and organizations, and journalists receive them, and it's basically like a story idea packaged for you. It eliminates your need to do extra work to go out into the world and find that idea. Now, you can choose to report on that however you want. You can choose to not report on it. You can choose to report on it very critically. You can choose to turn it into a poem. You can choose to do anything you want with it. But this is where probably the majority of stories that you read are coming from. They are coming from a press release which gets delivered to the journalist, and the journalist then goes and writes about it. The other sort of route that a story idea comes from is what I would call more organically. This comes from the journalist looking through arXiv, the journalist seeing things on social media, the journalist going to a conference talk and learning something interesting and nodding, the journalist having a conversation in a hallway. And this second route is a lot closer to, I think, how maybe a good research idea comes about. You're not going to find it mailed directly to you unless your supervisor says, do this, do that, and that happens when you're a PhD student, but hopefully not when you're, a PI. Anyways, my preference, I will, be perfectly blunt, I don't subscribe to a lot of press releases. There are some that I get, and it is good for me to know what's going on, but my preference is to sort of direct my own reporting by finding things organically. Okay.
Next question.
Sure.
So regarding the press release, can you explain, is there like a fast grab for these stories that science journalists try to be the first to report on?
Right. So this is the concept of embargoes. So for example, if you have a big paper coming out in Science next week, something like that, Science will put an embargo on that. That means that the journalist is not allowed to make that information public. The information is essentially private and limited, and the journalist gets access to it to do the reporting ahead of time so that they're not frantically rushing right after the paper is made public. There are good things and bad things about this. We can talk about this later, but in general, I would say that the point of these embargoes is, here's this juicy story, we've got a great result coming out in Science, go report on it. You have, essentially 5 days is usually what journalists get. And that helps more than 5 hours, so.
But I mean, so what is the process of who's chosen to write the story?
Oh, you mean like at a, so these,
Yeah,
I mean.
It's the journal that says, okay, we have our team that's going to report on this.
Well, okay, so for example, with Science, there is a website called Eureka Alert, and Science sends their press releases to Eureka Alert. If you are a journalist who is subscribed to Eureka Alert, you will get a weekly, inbox of here are the embargoed stories from Science, from Royal Society, from other journals. Nature, I think, still has their own separate thing, but yeah, you can browse through these, and journalists do, and they pick what they're going to write about for next week. They go and they interview people. They have time to do this. Within a publication, usually people have different specialties, so they will cover things. If your specialty is, astrophysics, you're going to cover the LIGO results. You're not going to cover some soft matter thing. Did that closer to answer? Okay. All right. Here is how I ended up writing a story on the fractional quantum anomalous Hall effect. It started up here in the top left with a tweet from Caden Hazard about a Bose-Einstein condensate of dipolar molecules. I thought, that sounds interesting. And so I read the paper, and I emailed an editor at Physics Today about it, and he said, you should write about that. And so I did. So I went and I talked to Sebastian Will at Columbia in February of 2023. No, 2024. Yes, sorry. And we had a nice conversation, and I saw his lab. And since I was at Columbia, I also went and I talked with Raquel Queiroz, who is someone I talked to about a story on twisted bilayer graphene. As we were having lunch, I said, hey, what's the most interesting thing that's going on in your field? And she said, well, you should really read about these TMDs. They're doing crazy stuff with this fractional quantum Hall without a magnetic field. And I said, okay, I'll read that paper. And I read that paper, and I thought, that's really interesting. And I somehow missed or forgot that she had also said it. And they've done something interesting in graphene as well. So I was kind of sitting around on this, not really sure what to do with it. And then later that week, I saw, oh my gosh, there's a paper. And it's in Nature, and it's on, they've seen the same effect in graphene. And then I saw, oh, look, they've got a talk at the March meeting. And I said, maybe I should write about this as well. And so that's how I ended up writing this story for Nature, is because I started off with this tweet in December of 2023 about the Bose-Einstein condensate. So that's one example of how you can sort of circuitously get from one thing to the next.
Can I ask something?
Sure.
You say you read these papers. Now, when I peruse physical review letters, and it's not in my field, I have a great deal of difficulty parsing what these are all about. So when you say you read these papers,
Yeah.
what do you really get out of this?
Right, that's a great question. How a science journalist reads a paper is, limited. It's my ability to understand all the methodology is minimal. When I look at a Hamiltonian, I'm not going to tell you. If you put a multiple choice question of which Hamiltonian is correct, I'm not going to tell you what the answer is. But I would say that in much the same way that editors handle things that are, not within their specialties. Hopefully they handle them well, but we endeavor to understand as well as we can. So I take my time with the paper. I go through. I'm sort of ruthless about it. I look for a money plot. I try to understand the implication, the significance. I'll get to what I think makes something newsworthy in a second. But the very important thing that I do is I go and I talk to experts, and I ask people, what is your opinion of this paper? I wasn't just going to read this and decide, oh, I'm going to do a story on this now. It's because I talked to an expert, and then I subsequently talked to many more people who said, yes, you should definitely report on this. So one way of understanding it is that science journalists conduct a kind of informal peer review. That is how we do our jobs. We rely on experts to inform us. We can develop a kind of journalistic expertise. It is different than scientific expertise. We cannot do the experiments, but we learn things along the way. All right. So I want to talk about commissioning and sort of how a story gets framed and conceptualized. Here's an email that I wrote to my editor at Nature, thinking about three sort of possibilities. One was sort of framing it as a discovery of the fractional quantum anomalous Hall effect. Another was talking about the potential for Moiré materials. And a third was just talking about the class of TMDs, these transition metal dichalcogenides. And then a very important thing is that I followed up after this email. I realized, oh, hey, there's this really interesting paper that just came out in Nature, and they'll be giving a talk. This is what's called a news peg. A news peg is this point of recency, this reason to write this story now. News pegs can be new results, they can be anniversaries, they can be all sorts of things. But a news peg is sort of essential for any kind of news story. Okay, what makes a result newsworthy? Don't read all this. This is just an example of an email that I put there. But there are three things that I think are very common among high-impact journals: novelty, sort of importance to the field, relevance outside of the field. I would add a couple of other things for journalists. One of them is unexpectedness. I think that it is much easier to sell a science journalist on a story if it is unexpected. If you are, if you have a great result which just conforms to theory, I wish it weren't the case, but it is, it is much more exciting. It is much more interesting when we can say, hey, people didn't expect this. This is a surprise. Similarly, recency is an issue. If you have, frankly, this becomes an issue sometimes where you have a paper that's been on arXiv for a year and there's a paper that has, just been published. Like, okay, this paper has actually been out there for a year. So recency helps a lot. We like reporting on papers that are just up to arXiv for that reason. Intelligibility is unfortunately another criterion. I do not report on string theory because I am not a string theorist, and I find a lot of it very opaque. On the other hand, a particle physics experiment where I can point at the detector, I can say to the reader, this thing is filled with liquid argon. That's pretty intelligible. And finally, popular interest. There is, to the sort of unfortunate dismay of condensed matter physicists, a lack of popular interest in condensed matter as compared to particle physics, which has been sort of amplified and talked about over the years. I think as Doug Nadelson's blog says, why should particle and astro have all the fun? What happens is, people hear these stories, they get excited about things like the Higgs boson, and nobody wants to talk about topological superconductivity, and that's a shame. But that is kind of a reality, is that these storylines do matter, and popular interest does matter for newsworthiness. Yes?
Yes, so just to ask you maybe an unusual question. So let's say you write for Nature. So Nature, Springer Nature has revenues of $1 billion, I remember, a year. And here the Library Council will pay $30 million subscription. So when you look at this from the perspective of money-making business, which Springer Nature is, what are the actual internal incentives to publish this or that? Is there an incentive to publish that correct facts? Like when you talk to your editors, does it come into play? Like, is it going to be helping the bottom line, or something helping the bottom line, or it's not an issue?
So there is essentially zero communication between the news side and the journal side of Nature. I will tell you the bottom line at many places, including Nature, is a concern about clicks by subscribers, a concern about people spending time on the story. There are metrics that are used. A story about black holes or quantum computing is going to draw more readers than a story about some theoretical simulation of a nanowire or something like that. That's just reality. And so, I mean, I hear what you're saying about, these other kinds of incentives, but the incentive for journalists and the incentive which is placed on us is about attention.
Yeah.
People want attention. That is the metric.
So are you mostly targeting kind of B2B, so corporate revenues, where it's individuals who are clicking around and ads revenue? So do you want people just to spend time on the site, or you want to drive out corporate revenue?
I don't want to do any of these things. I'm a journalist and I'm a reporter, and it's not my problem. But what I can say is that the people who are responsible for directing these things, there are basically two kinds of publications. There are subscriber-funded publications, like the New York Times, like Nature. These are publications which exist because they have subscribers, and there are publications which are driven by sort of ad revenue from people clicking on it and seeing internet ads. Those are things that are closer to like CNN or something like that, right? So the subscribers, I mean, I'm getting a little too into the weeds here, but basically what you should know is that the subscriber-driven models don't care as much about attention on individual articles, and they care more about how their subscribers feel about these articles. Okay, how to frame a story. So framing a story is really about what message you're going to want to end up conveying to readers. Again, you don't have to read all of this. I sort of summarized the main points here. If you don't frame the story, if you don't have a sort of direction that you want to drive the story in, your reader is not going to know what it is that they're coming away with. So I give a first stab at what we might do. We might say, Moray materials are essentially giving researchers unprecedented control over the stomping grounds of electrons. In response, my editor said, all right, what if we instead led with this weird electron behavior? And I said, okay, that makes sense. We're talking about the effect first rather than the material first. It might seem granular, but this is really genuinely important to especially to non-expert readers, to conveying what it is. But I would say for expert readers, if I write the same story with a negative framing or a positive framing, you will read that as a very different story. So the framing affects everything from the tone, it affects the content. So thinking about how the story is framed is crucial for journalists. Now, can anyone spot anything that we've gotten wrong here with this framing? Nicole?
What happened to the accent on the E?
That is a typo and a hastily written email, but that's not the issue. The issue here is that it's layered graphene because there's a twist angle between the graphene and the HPN. So we had it as twisted graphene, and this is the kind of thing which we make these mistakes. We hopefully catch them before publication. I don't remember exactly how or when I caught this mistake, but it was soon afterwards. I sort of frantically emailed, we need to update, we need to, and I'm getting to why I mentioned this, but, so this is actually a little bit more what journalism is like. There is not a 1, 2, 3, 4, 5 steps to reporting, to conceptualizing, commissioning, reporting, writing, and editing a story. There is editing that happens, then writing that happens, then more editing that happens, there's editing that happens, and then there's even more reporting that happens. As you saw with this commissioning, there was commissioning, then there was reporting, and then there was more commissioning because I had to change the title. There is a whole interplay through all this, and it is, it's a dark art to get the story published. Okay, here's an example of some of the reporting that I did for this Nature news story. I talked with two of the authors, the author Xiaodong Xu from University of Washington, who worked on the TMDs, and I talked with Longju from MIT, who worked on the rhombohedral graphene. I also spoke with 4 external experts. You will note that 3 of them are theorists, and that's because there were a lot of theory questions. And here's just an example. Again, this is small, and I don't expect you to read all of it, but we go through a fair amount of literature when we're doing this kind of stuff. You know, I'm reading old Physics Today articles. I'm reading Nature News and Views. I'm reading other articles in the literature. I need to understand the context for this development. This is a program called Zotero. Maybe some of you use it, but I store lots and lots and lots of articles there. And most of my stories look something like this. Okay. All right, now I'm going to get to the scientific background. Sorry? Yes?
So when you, I'm curious about the notion of expert. So because I sometimes worry by looking at some of the quotes and not yours. This is the perfect list of experts for this topic, obviously. But it seems like sometimes like a lot of this people who are not necessarily working on that topic but have a lot of social media presence get picked as experts. They're professors somewhere, but they've not necessarily been working on this topic. Yeah. Somebody who's adjacent, I'm like, why is this person being quoted? So does the reference list for you play a role in you figuring out? I mean, like Ashwin Vishwanath, you could just play it up. He's a condensed matter theorist in Harvard. How can he go wrong?
I talked with Ashwin because he had written a paper suggesting that there was an anomalous Hall crystal.
Yeah. No, right. So it's based on papers.
Yes.
Yeah.
I mean, that is, I would say, the primary way that I find people is based on papers. The secondary way is I talk to people and I say, who else should I be talking to? And the tertiary way is through somebody on social media. Social media has its uses. I think for fast-moving things, when I was reporting on LK99, there were not pre-existing papers on that. It was very helpful to talk to people who were on social media. On the other hand, for this, one of the things that was really important to me was there was a very nice Journal Club article by Sid Parameswaran, which summarized some of the theory developments around the rhombohedral graphene in particular. And so, it was very important. Well, I'll get to this in a second, but it was very important for me to talk with both Ashwin and Andre because they had very different views about Hartree-Fock. Okay. So some very brief review. The Hall effect. So back in 1879 or 1880, Edwin Hall was convinced that Maxwell was wrong, and he ended up being right. I believe the original conducting slab that he used was a piece of gold leaf on a glass plate, and he ran a current through it, and he saw that if you applied a magnetic field perpendicularly, what you got this Lorentz force, which essentially created a charge accumulation on one side, and you had a resulting Hall voltage. And this should basically look like this kind of continuously increasing resistivity as you apply a greater and greater field. But that's not how it turns out. And it is this really striking thing when you see these plateaus. And I think it's one of these real difficulties is conveying sort of the beauty of this result to, and this is a simulation. But conveying the beauty of the result to readers who might not understand why resistance plateaus are so striking, and I'll talk about some of my efforts to do that. But yeah, seeing these plateaus at integer values of a fundamental constant, really amazing. And I think that when you get to that and you see that in the same material, with just a little bit less disorder, you have this whole zoo, this whole spectrum of fractional states. again, it's difficult to explain to people why this is so fantastic. And I don't know that I've done a very good job in some of the articles that I've written. I'll be perfectly honest with you. I think it's something I'm still struggling to work on. And yeah, I think conveying some of the beauty of these physics results and some of the surprise. I mean, one of the techniques that we use as journalists is we use your excitement and your surprise at seeing these kinds of things. So if I have a nice quote from somebody that says, "Wow, I didn't expect to see this," that is sometimes more effective than me saying, "Look at this, it's great. Look at all these states. Look at all these. Look at the amazing way that these. I mean, some people have said, the electron gets split, but look at these fractionalized charges." Readers who are not physicists will not necessarily understand why that is so weird to have these fractionalized charges. All right, so here is the fractional anomalous quantum Hall effect on the left in twisted MOTE2, and on the right in rhombohedral multilayer graphene with an HPN interface. You will notice these plateaus are not quite as sharp as in gallium arsenide, and they are certainly not as nice as the simulations, but they are there, and they have been replicated or at least reproduced in the case of the graphene. I think for me, a big part of the newsworthiness was connecting these two things to the past sort of greatness of integer and fractional quantum Hall research. And I think that that came through to me from my own reading of the literature, but also from the conversations that I had to people who said, "Yeah, I did fractional quantum Hall stuff 10 years ago, and I stopped, but this got me interested again." And that's the kind of thing which is very revealing. When I go to a room and everybody's leaning forward to hear the next detail. Those are the kinds of things we look for as journalists. Okay. The intermezzo complete, and I haven't had anything thrown at me. I will go back to the science journalism. All right, some basic questions. How are we on time? Ooh, oh boy. All right. Okay. I'll speed through some of this. All right. So, some basic questions that we try to ask, and these questions pop up in my conversations with people. They also pop up in. Sorry. Yes.
Yeah, question. So you said that I understand the motivation behind new and very common results that as science journalists want, but it's also an aspect of science which is very slow and incremental progress.
Yes.
Do you think science journalism has a role to play there instead of just very passionate on this?
Yes and no. There are things that we shouldn't report because they will draw too much attention to them because they are incremental, and one of the ways that you make an editorial choice as a science journalist is to not report on something. On the other hand, I'll talk a little bit about reporting process and incremental results in the paper in a second. All right, anyways, these are some questions to think about. All right, so crafting a lead. So the lead is, you will note, misspelled. This happens frequently in journalism. We use it to distinguish it from more conventional terms. Similarly, we misspell paragraph as graph, G-R-A-F. It's a journalism thing, just bear with me. There are two ways to craft a lead. One of them is to summarize the most important aspects of a story. The other is to get the reader to read the rest of the story. You'll see that I sort of took a stab at enticing the reader to read the rest of the story here. I talked about, oh, here's the setting, drinks and bar napkins. And then I went a little bit more generic, but I sort of hinted at some fun, mysterious, intriguing electrical properties. And we ended up not doing that. So here's what we ended up with. So when, last May, who, physicists at the University of Washington, how scientists ran an electrical current through 2 atom-thin sheets of molybdenum ditelluride. What the electrons behaved similarly to particles with charges of -2/3 or -3/5, and sort of a why. that this is truly odd that the electrons did this entirely because of the innate properties rather than an applied external magnetic field. So, I'm not saying that I was thinking about all of these questions when I was writing this, but it's good to answer these questions. And oftentimes, if you write something and you leave some of these questions unaddressed, your editor will come back to you and say, well, this, please elaborate on this. This needs to be addressed in your story. Okay, after a lead comes a nut graph. A nut graph is the nutshell, the article in a nutshell. And so in this case, our lead explained some very important information, which led to this, which is the focus of the article, which is the fractional quantum anomalous Hall effect in rhombohedral graphene. And the reason we chose this is twofold. One is because it's more recent than the result in the TMD. The other is that it's frankly more unexpected. There was not a prediction. There were predictions for the effect in TMDs. They were at slightly different angles. It was not quite the same, but the graphene was kind of out of left field, and a lot of people were very excited about that. Okay. Every story that you read is going to have some version of this. Why should the reader care? Why should the reader keep reading? We have to explain it because it's not obvious. In this case, there's not really a clear application. So what we cite is a fundamentally interesting bit of physics. And I didn't include this here, but I have a nice quote from Pablo Herrero about, this is great stuff. We should all be, dropping everything and working on this. And Pablo is very excited about this. So that's sort of, and the implication comes through in his quote. Okay. So when we have scientific background, there are a couple things that, we think about, what do we want to convey? I can't explain everything about scientific background. So what are some of the key things? Well, I want to explain that the electrical resistance is quantized and it's in the transverse. I also want to give an intuition about the resistance plateaus. So here's my stab at doing so, which is that, and I'm studiously, as you can see here, avoiding any mention of Landau levels or other jargon. It's a little bit like vehicles on a road moving at the same speed, even with more traffic. So even as you're increasing the charge density, the resistance is the same. And this is not perfect. No analogy is. But I think it gets a little bit in the direction of giving readers a sense of why are these resistance plateaus so weird or wonderful or beautiful? Okay. Honestly, for this, I just wanted to say these fractional charges are weird and they're different. Electrons, they've got integer charge. Fractional charge, it's not electrons. Similarly, here I wanted to sort of get at some of what makes the FQHE notable. I didn't include it here, but again, I have a quote from Ashvin talking about how it's just a world apart from the integer quantum Hall effect, and I can't get into discussions of topology or strongly correlated systems, but the idea is to give readers a sort of a taste of that and to give them a justification for why we care. Okay. So more on the scientific background. I include this here because I'm showing how you can sort of say some of these things without referring to jargon. Later on, I talk about an effective magnetic field. These are sort of what we hope to do is they are simplifications within reason, and there are unreasonable simplifications, but one of the problems is if you aren't simplifying, you are more likely to obscure the truth and be unclear because your reader is not going to know what's going on. And then another thing is just, I want to introduce mores as a concept, and there's more on here about, more on mores, about what they do. But there are a couple of key points you want to hit in the scientific background. What are the sort of the essential ingredients that the reader needs to know to grasp the significance of the article, of the research that's being discussed, and really appreciate a little bit of the science. Okay. I like words, I'm a writer, but I'm really, really aware of the limitations of words. And so, one of the things that we try to do with complicated stories is, when possible, have some kind of graphic. So in this case, we used some of the graphics, obviously with permission and working with Long, from his article. And what we did is, we sort of broke it down into 3 parts. We have a side view of the rhombohedral graphene and the HBN to sort of give readers a sense of how this sandwich is constructed. Then we have a top view. There's the moire. And then we have, here's the result. This is a very simplified chart. You can see it's just the transverse resistance. Everything has been stripped from the plot. If we go back, oops, there we go. You can see that there's a lot more going on here. And for the reader's eyes, we just stripped it down to that. All right. So this is sort of to your question about incremental stuff. One thing that's important to me is to document process. So, automatically succeed at discovering the fractional quantum anomalous Hall effect. If it was that easy, everyone would have done it. So I wrote about a failure that they had, which was not finding it at 1.4 degrees. And then I wrote about a success. And then I wrote about a replication attempt. And I think these are the kinds of things which maybe give readers a sense for how science is conducted. What are some of the things that happen? What's important? What's needed? Okay. Further context. So, when you have 2 results, you often want to include some kind of comparison between the 2. And so I asked people a lot of questions about, you can ask direct questions, is your experiment better than your competitor's experiment? And people will give you all sorts of interesting answers. In this case, I chose to focus on sort of the material properties of MOTE2 versus rhombohedral graphene. So the MOTE2, as someone described to me, is like 2 sheets of saran wrap. These are flimsy materials. These are really difficult to get them to behave. The graphene is also like that, usually because it's stacking homo bilayers is terrible work. But Long actually does something different, which is that he, observes these these rhombohedrali stacked arrangements and then cuts it out of the graphene. Anyways, I focused on some of the properties here about temperature dependence, and I sort of alluded to the fact that the graphene is a cleaner and material with less disorder. The point is just to give readers a sense of why these things are different and why scientists care about that. Another thing, very exciting, unpublished results. We love unpublished results because that's a scoop, that's news. Nobody else has reported that. Unless you read it, unless you heard it from Long himself, you didn't know this. That he had seen this effect in 4 and 6 layers of graphene. However, you will also note that I do not say this effect exists in 4 and 6 layers of graphene. We said, Ju says that he has seen this. This is this is us being careful. This has not been peer reviewed. It has not been published. Nobody else has looked at this. This is just what he's saying. But we include it, and I think it's good to get this kind of stuff out there. I personally enjoy it because, again, it's sort of it's not rumors, but it's on the record. It's yes, he has seen this in these other layers, not just 5 layers of graphene, but also 4 and 6. Okay. Right, the reason I talked to multiple theorists, because they disagreed, and sometimes they disagree strongly. In this case, Ashvin had this theory about the moire not mattering at all, and there's some interesting justification why, is because the effect is actually at the other end of the graphene, away from the moire potential, and there are interesting things that happen if this exists without the moire potentials. You can have this a state called an anomalous Hall crystal. However, I talk with other people because I want to make sure that I'm getting a complete perspective. And again, this was also in the Journal Club article, is that people had disagreed with each other. Pardon me. And so Andre Bernevig expressed his sort of difference of opinion, and I think the way he put it to me was, yes, the Moirai potential probably matters a little bit. It probably is at the 3%, 10% level. This is what was sort of thought back then, and I think this is sort of coming to be the consensus now, is that it matters some for sort of fixing the effect. I'm almost out of time, aren't I? All right, I'm gonna move forward. Okay, stories tend to end with a kicker. This kicker is important because it is what the audience leaves with. We tend to pay a lot of attention to the beginnings and endings of things, and so as journalists, when I say we, I mean as humans, and so as journalists, we also pay attention to this, and so one of the things I wanted to have readers leave with is there's lots more to come on this. This is undecided. Okay, here's an example of something that does not make it into the story. Xiaodong gave me this really interesting quote about how he saw Long's data and he said, wow, like, why did you show me my own data? Because he was so surprised to see the effect in a different material. I didn't include this because I had a number of conversations with both of them about this, and in the end decided it was ambiguous enough and confusing enough to the reader that it wasn't serving the reader well. And also, if we look back, there are differences between this data. For one, there are more plateaus in the rhombohedral graphene. But yeah, I think that one of the most important things that sometimes ends up happening in a story is not what you include, but what you choose not to include, because there is a whole lot that gets left on the cutting room table. Okay, I'm going to speed through this. So a feature differs from a news story in three primary, so a feature is a sort of more narrative, longer form article, and it differs from a news story. There's this nice summary here that I'm sort of cribbing from. It is intimate, it is literary, and it is adventurous. And we'll see how these criteria sort of align with what I wrote. So this is a feature I did about 2 months after the fact. I think it was in May or June of 2024. It's for a magazine called Quanta. And it is about, again, the discovery of these fractional quantum anomalous Hall effects. Just a very quick sort of note about reporting. Here, I spoke to a larger number of people about a variety of things, and I had multiple conversations with most of these people because the process of reporting a feature is much more intensive than reporting a news story. In particular, I had a lot of conversations with people about the fractional quantum spin Hall effect, which also did not make it into the Quanta story. Okay. A feature lead is different than a news lead because a feature lead says, come, sit down, have a cup of tea. Let's go on, put your feet up. We're gonna be a little while. I'm not giving you the news directly. We start off with, the history of the electron, right? It's not last May or last Wednesday, there was this big new result. Okay, one of the things you can also do is you can, really step back further and talk about the history. So I actually got to include, 1879. Okay, good to know it was 1879, not 1880. Edwin Hall. You can get to more detail. Again, still trying to avoid saying Landau levels here, although sometimes, I confess, we can avoid the jargon too much and it becomes actually confusing. I don't know that this one sort of ended up there, but it can happen, and it is, some jargon is important. Okay, literary touches. So there are things like this rhetorical question at the end. You're just probably not going to see that in a news story, or not as often. And this little thing, you know, the interacting electrons poised just so. There's language that you're just not going to find in a news story that you are almost obliged to put into a feature story because it has a different style and tone. As for intimacy and adventure, there are a lot of things to detail in a story about the fractional quantum anomalous Hall effect, and an intimate biography of a scientist and an adventure to the Arctic or a jungle are not one of them. Instead, the intimacy comes through a sort of like a closeness to the experiment. The adventure comes through a tracking the developments of these experiments. And so you get sentences like this: adjust the twist angle by ½ degree and the superconductivity disappears. I wrote that sentence almost as like as you might see in like a guidebook or something like that. Do this, do that, right? It's not they did this. It's you could be there doing this yourself. Okay, I'm almost done. All right, concluding thoughts. I told you I was getting there. All right, just reviewing the principles again, process, and then a couple takeaways from the practice. So one is, I hope it's clear that crafting a story is non-trivial. There are a lot of editorial choices to be made. Two is that a lot of what is difficult is what doesn't show up in the text, or what you choose to omit, because there is so much more that you end up gathering. Putting something in the text is a very deliberate choice. Choosing to cover a story is a very deliberate editorial choice. And finally, clarity is this big constraint. Clarity prevents you from really being able to talk in detail, to even tell the truth sometimes. It's making things clear and understandable and simple is a constant battle with the other principles. And it's people will be even upset at you because you've made something clear, but you haven't cited them, or you haven't properly credited them. There are a lot of things that get sacrificed in the name of clarity. And if you are upset at a journalist, it is probably because they did something in the name of clarity, and they may or may not be sorry about it, but they did think about it, almost assuredly, because it's something which is always on our minds. And yeah, all right. So I just want to acknowledge my editors, my fellow reporters, and to you, the scientists, for answering my many questions. Okay, that's it.
Lots of questions, but how much time do you find yourself spending per story?
Yeah.
Do you rely on prior expertise in a topic, or to like help start something, or are you going to dive into any new physics topic and get all the background you need?
Yeah. So it really, really depends on the story, but in general, I would say a news story takes 20 to 40 hours. It can take less if you really know what you're doing and it's really short. But yeah, I mean, usually you can't do more than 2 news stories a week. As for prior experience, prior knowledge, yeah, I mean, one thing which is, so I wouldn't have gotten assigned the quanta feature story if I hadn't written the news story beforehand. And it tells the editor 2 things. One is that other people are interested in this, and that I can write about it. Yeah, there's a lot of work that gets done up front when I'm learning about a topic. I have to familiarize myself with lots and lots of different things. I have to learn about the history. It helps tremendously to have some background, having previously written about something.
I'm wondering about situations where something happens that contradicts something that people have believed all their lives. I think in particular about when Pluto got voted off the island of the planet. My brother, who was not a scientist, really, really upset about this. And I'm wondering if there's something one can say people understand that science is not theology.
So, sorry, the question is,
The question is, how do you, is there a way to deal with informing the public that this is not some travesty, that science isn't capricious, that there's a real reason Pluto is excluded from the planet, and that this is a natural thing to expect to happen to us?
yeah, so I was probably in grade school when that happened, but I can talk about other disappointments. So, I mean, one of the recent disappointments has been the lack of evidence for beyond the standard model physics, and this happens with numerous experiments, and odds are if you're reporting on a particle physics development, it is about some, we didn't find dark matter again, or something like that, right? And so you have to, you have to talk to people, okay, we've got a null result, or for example, in condensed matter, if you have something which everyone's very excited about is a room temperature superconductor, and it turns out not to be. These things are disappointments, and some people get very emotionally attached to these kinds of things. And I would say that the way that you sort of let the public down gently is that you explain that the scientific process worked. You found out new details which updated your understanding. I mean, in the case of Pluto, it was that I guess its orbital eccentricity or ellipticity is highly non-standard, and it's not spherical enough, and that there are other bodies which we would have to consider planets if we were to consider Pluto a planet. And it's not super satisfying, I confess, but I mean, personally to me. But those are the kinds of things I would include in an article. You don't just say, scientists have decided by fiat that this is the case. Is you include the rationales for these things, and you hope that people will forgive you. But sometimes they send you angry emails anyways.
I'll ask a quick question. So you showed the example of, a positive story, a positive result. That's metaphysics, the fraction of 1 quantum. And I'm sure generally you talk to people who are very positive about it, plenty of ideas and so on. But how do you approach the other case versus the misconduct case, or the case where there's a malicious actor, perhaps, and you're trying to get at the truth? Do you approach, do you try to get your sources and your information in a different way? Or how do you, that must obviously be a difficult thing.
Yeah.
How do you approach it?
Well, I mean, I guess the first thing I should say is that in the beginning, you don't know that there is a malicious actor. This is hindsight is 20/20, right? If you knew exactly, if you knew that a crime had been committed, it's much easier to unravel that. In the case of something like a fraudulent high temperature superconductor, yeah. So the way that you go about looking for sources and talking to people and the questions that you ask, these are different. And I mean, one of the things that I try to assure people that I have conversations with is I am going to be fair, I'm going to be rigorous, and I'm going to be very cautious about going forward and publishing information on this. I mean, I have to be because my editors and publication won't let me because they would worry about being sued. But it's important for me to reassure people that we're not just out there to publish the most sensational details. I think that the way that at least I view my work is it is as part of the scientific correction ecosystem in that case. If the concern has reached me, that means something else along the way has failed. Not all concerns end up being substantiated, but and I often don't report on them if that's the case. But regardless, the concern reaches me, and then yes, you do go about it in a different way. You talk to people sometimes on background or off the record because something is sensitive. There are lots of different considerations. I'm afraid I don't have time to get into all of them. Sorry, okay, yeah.
Yeah, go ahead really quick.
Okay.
So,
Yeah.
I want to bring up an elephant in the room.
Sorry, you want to bring up what?
The elephant in the room.
Yes.
And it seems as if us scientists have lost a certain amount of credibility with the public. And I'm saying that because the large number of people who seem to be able to question climate change, the large number of people who may question vaccines, you know, it seems to be a real problem, and it's not clear what we could do about it, but what do you think about all that?
Well, I mean, there are difficulties in quantifying exactly how scientists have, lost credibility. You'll get people who will say, no, I won't take any vaccines, but I do like my doctor. I do trust scientists. I mean, there are plenty of people who are anti-vax, but very concerned about climate change. It's not all or nothing. It's a little complicated. But what I would say is that, unfortunately, it is not my job to, make sure that science is seen credibly. That is a science communicator's job. My job is to report the truth. And
I'm not asking you about your job.
okay, but
I'm asking a more general question for us.
okay. Well, I mean, one thing that can help is sort of, making yourselves heard in your communities and conveying that, not that you're always right, but that you have a process, that you have, this rigorous way of looking at the world. I mean, I had a lovely conversation with my grandmother after she took a continuing education class on astrophysics and cosmology, and she just would not believe that dark matter existed. And we went back and forth on this for a while. And it was really interesting to get this kind of feedback from someone who is, really, really bright and has just absorbed a lot of this material, but fundamentally disagrees or finds it hard to trust. And I should clarify that my grandmother is completely, pro-vax, understands climate change and stuff. But dark matter is an invisible particle, and for her that was very, very odd. And she was just saying, well, what if it's dust messing at the instruments? And it's very hard to get past this. There's a sort of intuition gap, I think, sometimes when it comes to the things that we want to convey. And so, I can talk about baryon acoustic oscillations or whatever, but like at the end of the day, if you don't believe that it's more likely that there is some kind of, invisible particle out there based on the evidence than that scientists and the whole body of research are wrong, you're not going to believe in dark matter. It doesn't matter how many things I can say to you. It's that this thing which is being posited, that dark matter or that vaccines can help you. So I guess what I'm saying is understanding what the obstacle is. It's not necessarily a lack of evidence. There's often a fixation on a single thing. And I think in the case of sort of trust in science, there is, I think, a lack of trust in science comes from a lot of places, but one particular place it comes from is a sort of a distrust in the institutions of science, not necessarily the scientists themselves. So a distrust in pharmaceutical companies. There are reasons to distrust pharmaceutical companies. Johnson & Johnson, which supplied many vaccines, currently has a lawsuit against them because of some issue with the talc and baby powder. I'm not saying this as a solution, but I think it is helpful to understand how and why people form sort of, have difficulties getting over trust issues. I'm not sure, I don't know that I can answer your question satisfactorily, but hopefully I tried. Anybody else?
The problem is you're up against a decades-old political, a concerted political, a targeted political movement to try to discredit at least some parts of science. And which is inconvenient to some interests. And they try to sell it to people as though the government is going to, I don't know, it's going to take away their SUVs and make you ride a bicycle or something. You know, or whatever the case may be. And the problem is, this is going to have real world consequences. And whatever science, whatever problem the science journalism has in trying to translate the esoteric of maybe the solid state quantum mechanics fun to make them understand some of these interesting things. It's not getting anywhere, even in trying to explain what 200-year-old 19th century thermodynamics, you know, if you have an adiabatic system, you pump energy into it, if the temperature goes up inside. And that's the problem here. You're up against a political problem, not so much an understanding. And I don't know what we're going to do either, because it requires resources to do that.
Yeah, resources that freelance science journalists don't have, but
Okay. All right, but we should wrap up here. So thank you very much, Dan.
thank you all.